Okay, so this is still chapter 6. We're on part 6 of the chapter. So we're going to talk about recommended fat intakes. And again, we've talked about some of this already. The AMDR for fats, which we've talked about in previous chapters, should be within the range of 20 to 35% of the total calories that you consume per day. So 20 to 35% of calories should come from fat. So obviously fat is an important part of our diets. The majority of the fat that we consume should be in the form of unsaturated fats. Not telling you not to have any saturated fat, but again, the majority should come from unsaturated fats. And cholesterol should be as low as possible. I mentioned this in the previous video that the most current U.S. dietary guidelines does not put a number on this. It just says as low as possible. Staying below 200 milligrams per day is a good recommendation, especially for individuals who have high bad cholesterol, so LDL levels, who have diabetes, who have cardiovascular disease. Staying under that 200 milligrams per day. But again, a number is not stated in the new guidelines. It's stated to have this be as low as possible. And so that'll be reiterated here on this slide. So again, the percent fat of calories should be between 20 and 35% of our daily caloric intake. Saturated fats, eat as little as possible. Saturated fats, according to the dietary guidelines, should account for less than 10% of calories starting at age 2. So that's a little bit nuanced. And again, the therapeutic lifestyle change diet over here recommends even less, so less than 7% calories. Okay, and saturated fats, should be replaced with mono and poly unsaturated fats. Trans fats should not be consumed, right? Eat as little as possible. Again, as of 2018, trans fats are no longer on that GRAS list and are no longer added to foods in the U.S. Okay, so again, this is a partially hydrogenated fat, which is not good. Unsaturated fats, these are healthy fats, right? So a healthy eating pattern includes some oil, so we do need fat in our diet. Again, mono and polyunsaturated fats are going to be better. So the majority of our fats should come from unsaturated fats. Omega-6 and omega-3s are unsaturated essential fatty acids. And again, we need these in our diet. And here are some numbers. Again, don't feel like you have to memorize the numbers, but about 5 to 10% of our fats should come from omega-6 and a little bit less from omega-3. So again, you want to have, about a 5-to-1 ratio of those. That ratio is pretty important. And then lastly, dietary cholesterol. Again, the dietary guidelines say that you should, minimize intake while eating healthy. They don't put a number on it, but again, it's recommended here. The TLC, the therapeutic lifestyle change diet, recommends under 200 milligrams a day. Okay. I want to talk about the Mediterranean diet. This is in your textbook. It's a diet that's touted for heart health. And in this diet, it really emphasizes that the type of fat that you consume really does matter. There is some scientific evidence to suggest that you could consume up above the AMDR, so up to 40% of your calories from fat, and still be, healthy, not have cardiovascular disease, if monounsaturated fats account for most of the fat intake that you get. So again, monounsaturated fats have been shown to lower LDL, bad cholesterol, and increase HDL, good cholesterol. Where could you get, this type of monounsaturated fat? So fats like olive oil, avocados, nuts, seeds, canola oil, fatty fish. Those are all rich in monounsaturated fats. The traditional Mediterranean diet has been shown to have the lowest records of rates of chronic disease, low levels of cardiovascular disease. Okay, the guidelines of this diet: olive oil is the main fat, so again, monounsaturated fat. Abundant intake of fruits, vegetables, whole grains, beans, nuts, and seeds. Minimal amounts of processed foods. Food should be fresh. They should be local. Limited eggs and red meat, regular exercise, and moderate drinking of wine. Okay, so this is considered to be a heart-healthy diet, which again has shown low levels of chronic disease. Okay, let's talk about intake of fat for individuals in North America. So, as usual, I'm telling you, we overconsume saturated fats, right? We overconsume fat in general, but we do overconsume saturated fats over mono and polyunsaturated fats. So that's not good. Omega-6 fat intake is usually good. It's usually high. And omega-3 fat intake is usually low. Again, the ratio is off. The ratio needs to be like a 4-to-1, and instead it's like a 15 to 20 to 1, and so that's not a good thing. It needs to be in balance to make sure that individuals don't get chronic diseases like obesity, cardiovascular disease, diabetes, all of those things that I keep mentioning. Again, just to reiterate, omega-6 fat is usually high. Again, oftentimes omega-6 fatty acids are hydrogenated, fully hydrogenated, not partially, so it's not trans fats. And they're added to processed foods because vegetable oil is cheap. And so we overconsume ultra-processed foods. And that's where we get a lot of those omega-6s from. Okay, so Americans have work to do. Easier said than done, right? Okay, so fat digestion and absorption. So let's go back to the digestive system. So we're going to talk about both mechanical and chemical. There's really chemical digestion shown on here, but I'll mention both. So lipid digestion starts in the mouth, right? So there's mechanical digestion, chewing, right? Your teeth are cutting up food. Enzymatic chemical digestion also starts in the mouth. So there is the enzyme. We talked about this before, back in chapter 4, I believe, but just to mention it again, there is lingual lipase, which is secreted from the base of the tongue. That's going to start to break down lipids in the mouth. Okay. We then swallow our food. That's called the bolus. It travels down our esophagus. It goes through the esophageal sphincter into our stomach. And in our stomach, we also have some mechanical digestion happening in there. And we also have enzymatic. So inside of the stomach, we have gastric lipase. Okay, so there is some digestion of lipids in the stomach as well. Okay, we have churning, which is that mechanical digestion, kind of mixing everything up. Most digestion, however, of fats is going to occur in the small intestine. So we said the same thing about carbohydrates, right? So food is going to move, it's going to be in the form of chyme, and lipids actually kind of sit on top of chyme because they're insoluble, so they don't tend to mix well with digestive juices. They're going to pass through into the small intestines, and in that very beginning of the small intestine, bile will enter. Bile, remember, is going to be produced by the liver. It's stored in the gallbladder. It's going to enter into the duodenum, that beginning of the small intestine, through the common bile duct. And once it's inside of there, bile is going to be responsible for emulsifying fat. So it breaks it down into these tiny fat droplets called micelles. And this process increases the surface area of fat, allowing for enzymatic digestion, to continue. And so also in the small intestine from the pancreas will be pancreatic lipase, as well as other enzymes. And again, these are going to break down lipids into their component parts, glycerol and fatty acids. Okay. Here is a picture of that process. And so again, you've seen this same picture throughout. So again, digestion starts in the mouth. It continues in the stomach. Most of digestion happens in the small intestine. Okay. Not only does most of digestion happen in the small intestine, but the same thing can be said for absorption, which we're going to get to on the next slide. But just to mention briefly before we go to the next slide, the large intestine is the final stop. Less than 5% of fat ends up in here. There is some digestion that is done in the large intestine by microbes, and fat that gets digested here can be used to feed colon cells. You get small and medium chain fatty acids that are produced in that way. In any event, any excess is excreted. Okay, but again, 95% of fat is digested and absorbed in the small intestine. Okay, so here we go. Let's talk about absorption. So again, you've got glycerol and fatty acids now. Those have been completely broken down, and then they're going to be absorbed in the small intestine. So 95% of dietary fat gets absorbed in the small intestine. Short and medium chain fatty acids are going to be transported directly to the liver via the hepatic portal vein. Okay. Long chain fatty acids are a little bit different. Long chain fatty acids are going to be what we call re-esterified, repackaged into triglycerides. Okay, so there's two different pathways here, and this will be evident on the next slide. So short and medium chain fatty acids go to the liver. Long chain fatty acids get put back together into triglycerides, and those, along with dietary cholesterol and fat-soluble vitamins and any phospholipids, they get packaged into these structures called chylomicrons, which are a type of lipoprotein. That is what is shown here in this figure. So the pinkish purple spheres with these little yellow tails, these are phospholipids. And then within the phospholipids, there's also some protein molecules. Okay, some proteins here. In purple is proteins. Free cholesterol is shown in yellow. Okay. So this is a, phospholipid cholesterol protein coating or, sphere that forms around this core, which is filled with triglycerides. And so triglycerides are shown on the inside here. Okay, so we've got triglycerides, fat-soluble vitamins, all kind of packaged up into these phospholipid surrounded lipoproteins. Okay, they're called, again, chylomicrons. Why does this happen? Well, we want to transport these triglycerides, through the bloodstream. And they can't just go through there on their own because they're not soluble in water. And so if we package them like this, the phospholipids, right, these polar head groups, they can associate with water. And so this makes these lipids soluble in water, which allows them to enter circulation. Okay, so a little bit more difficult than when we talked about carbohydrates. A little bit of an extra step here. Okay, so let's go to this figure. Hopefully you can see this. So we've got fat, right? It's been ingested. It's going to start to be digested. Bile is going to come in and break this apart. Okay, lipase from the pancreas is then going to break it up even more. And so here we go. What's going to happen is glycerol and fatty acids start to get absorbed into these cells lining the small intestine. These get put back together into triglycerides. And those triglycerides then get packaged with phospholipids, cholesterol, and proteins into those chylomicrons, the lipoprotein. These then travel through lacteals. Remember, these are small lymphatic vessels, eventually entering the lymphatic system, where they're eventually dumped into circulation. So this is how triglycerides, dietary triglycerides and dietary cholesterol get to the cells of your body. Okay? Again, just to mention quickly, short and medium chain fatty acids, they don't do that. Instead, they get transported through the portal vein to the liver, and then the liver either uses them or they will also be put into circulation. Okay? So that is absorption. Ooh. Okay. So again, this is going to so digestion happens mouth, stomach, really in the large or small intestine. And then absorption happens in the small intestine, and those triglycerides will then enter into either the lymphatic system, then the bloodstream, or the liver, then the bloodstream. These triglycerides, this fat, can be used immediately for energy, or they can be used to make lipid-containing compounds like hormones or bile, or they can be stored in adipose tissue or in muscle for later use. Okay. So let's briefly go back to transport and make sure we kind of have this, and we're going to add some more pieces to this. So again, absorption happens in the small intestine. We need to get triglycerides in the lymphatic and eventually the bloodstream in order to get these triglycerides to the cells in your body so that they can be used for energy or stored. Okay? Triglycerides, lipids in general, are not water soluble, so they can't just be dumped into the bloodstream. That doesn't work. So they have to be packaged into these things called lipoproteins. Okay? So in the small intestine, triglycerides, cholesterol, phospholipids get packaged into these things called chylomicrons. So that's this word here. So chylomicrons are going to pick up dietary fats, dietary triglycerides, and deliver them via the lymphatic system and then the bloodstream, the cardiovascular system, to all the cells of your body. Okay, so that's how dietary cholesterol gets to where it needs to go. I want to introduce you to some of these other ones, and some of these are going to look familiar to you. These are all types of lipoproteins. So chylomicrons, dietary fat, 2 cells. Then there are these very low density lipoproteins, so VLDLs for short. VLDLs are going to be produced in the liver, and they're going to also transport triglycerides and cholesterol to your body cells. Okay. What will happen is as very low density lipoproteins start to lose triglycerides, so when they start to dump triglycerides off at your cells, they become intermediate density lipoproteins, so IDLs. So these have just lower levels of triglycerides. Okay, and then when these start to dump off triglycerides at cells, they become low density lipoproteins, or LDLs. This is what we term bad cholesterol. So an LDL is going to be kind of the remnants of VLDLs. Okay, VLDLs again originate from the liver. They're carrying triglycerides to the cells of your body. As they dump off triglycerides, they become less and less full of triglycerides, and they tend to again lower the triglyceride level, but there's still levels of cholesterol. And so low density lipoproteins are low in triglycerides, but high in cholesterol. And so that's why we term them bad cholesterol. HDL, on the other hand, these are going to be a little bit different. So again, they're going to be generated by the liver and the intestine. They are high density lipoproteins, HDL. And this again, we label as good cholesterol. The job of HDL is to travel around our bodies and to pick up cholesterol from our tissues, from our artery walls, and to deliver that cholesterol back to the liver where it can become part of other compounds again. Okay, so HDL is kind of like a scavenger. It's going to pick up cholesterol and bring it back to the liver so it can, either be used, or it could end up, being put back into the intestine, and it could get bound by fiber and you can excrete it. Okay, so HDL lowers cholesterol levels. So it's considered to be good. Okay, so what are these things? So again, lipoproteins, this is going to be this core of lipids, so triglycerides, surrounded by this shell that's made up of proteins, phospholipids, and cholesterol. It is the way fat circulates in the blood. It can't circulate without these structures. Okay? Because it's insoluble. Ooh, I skipped it. Okay, so again, we saw this picture already. This is what a lipoprotein looks like. Again, triglycerides and fat-soluble vitamins are going to be in the internal parts of this. And then the coating is going to be made mainly of phospholipids as well as cholesterol and proteins. Okay, and again, this is the way that fat is delivered from our small intestine or from our liver to all of the cells in our body. And so again, if we look at the contents inside of these, if we look at chylomicrons, so again, these are generated in the small intestine. Dietary fat is picked up in these. If you look inside of those, they contain about 80 to 90% triglycerides. Okay. VLDLs, so very low density lipoproteins. Again, these are going to be generated mainly in the liver. Again, it's carrying lipids, triglycerides to our cells, 55 to 65% triglycerides, and then they have cholesterol, phospholipids, protein. If we look at LDLs, so this is bad cholesterol, low density lipoproteins. These are the remnants of VLDLs, so after they drop off triglycerides to cells, LDLs end up low in triglycerides and high in cholesterol. Okay, and so that's not a great thing. HDL, on the other hand, is low in triglycerides, lower in cholesterol, higher in proteins. And so again, the job of these is to act as scavengers and pick up cholesterol. Okay, so on this next slide here, I've kind of already said this, but here it's in table format. So again, chylomicrons, these are lipoproteins. Their primary component is triglycerides. Their job is to carry dietary fat after digestion from the small intestine to the cells of our body, where it's either going to be used for energy or stored. VLDL stands for very low density lipoprotein. Again, primary component are triglycerides. Again, they're going to carry lipids, both taken up and made by the liver to cells. Okay, so these are generated by the liver, and they're going to deliver triglycerides to cells, again, to either be used for energy or to be stored. So chylomicrons and VLDLs, kind of do the same thing, but they have different places of origin. LDL, its primary component is going to be cholesterol. These are remnants of VLDLs. Okay, they're going to carry cholesterol made by the liver and other sources to cells. Again, LDL is considered to be the bad cholesterol. High levels of that in the blood are not good. And in the next part of the chapter, we'll actually talk about those levels. And then HDL, high density lipoprotein, these are going to be primarily composed of protein, low cholesterol, low triglyceride. And again, they're going to be produced by the liver. And their job is to help remove cholesterol from cells and in turn get rid of cholesterol from the body. It's going to bring that back to the liver, and the liver in bile puts cholesterol back into the small intestine, and some of that cholesterol can be absorbed by things like fiber and be excreted from the body. Okay, one more slide just to show you again LDL versus HDL. So LDL is bad cholesterol, low density lipoprotein. Again, these are formed in the blood from remnants of VLDLs. They are high in cholesterol. HDL, high density lipoprotein, again, synthesized in the liver, released into the blood. Their job is to travel through the body via the blood and pick up free cholesterol. And then it's going to transport that cholesterol back to the liver. So they are scavengers, so they're going to get rid of cholesterol. And that's it for this part of the chapter. In the next part, we'll talk more about this when we get into some health concerns. We'll talk about cardiovascular disease and kind of where these levels should be.